Good morning everyone. Welcome to today's maths class. We are in the chapter surface areas and volumes and we are in the exercise 13.3. We have completed 5 problems. Let us do the problem number 6. Okay. How many silver coins 1.75 centimeters in diameter and a thickness 2 millimeters must be melted to form a cuboid of dimensions 5.5 centimeters into 10 centimeters into 3.5 centimeters. Okay, now so look at this. Here I have some coins. So in the problem he has mentioned that silver coins, but I have taken normal coins. Now look at this, each coin diameter is given 1.75 centimeters. It is approximately like that only, and the thickness is 2 millimeters. Thickness, okay, is 2 millimeters he has given. And see here, if you keep coins like this 1, 2, 3, 4, 5, like that, if you keep many coins, you will get a cylindrical shape. All these coins will form a cylinder. Okay, if the number of coins increase, the height also will be increased. Okay, the height will be depending upon the number of coins. If I remove one by one, if I remove the coins one by one, the height will be decreased. Okay, so these are all cylinders only, but as we remove the coins, the height will be decreased. Now see, finally I have only one coin. So it is also can be considered as a cylinder with height only 2 millimeters. Why? Because he has given the thickness of the coin is 2 millimeters. So the thickness of the coin can be considered as its height. Okay. Now here, if you take many coins like this, you will get a cylinder. See, let us consider these all coins. Keep on one on each other. Now how many coins do we have to take to get a cylinder, to get a cuboid with these dimensions if you melt and recast? Okay, we need to find the number of coins required to make a cuboid with these measurements. Okay, now let us write the dimensions of the coin. Now what is the diameter of each coin? Is equal to 1.75 centimeters. Is it centimeters? Okay. Therefore, radius r is equal to 1.75 by 2. Let us take it as, if you remove the point, you will get 2 zeros. 25 sevens, 25 eights. You will get 7 by 8 centimeters. This is the radius of each coin. Now, what is the height of? So height we don't know. Let us leave like this. Now, here we have to get the dimensions of the cuboid. The dimensions of the cuboid is equal to L, B and H. So let us take the biggest value as L 10 centimeters, 5.5 centimeters breadth, and the height is 3 centimeters. Okay, he has also given the thickness of each coin. What is thickness of each coin? Is given 2 millimeters. As we have all the other dimensions are in centimeters, we need to convert the thickness of each coin also into centimeters. So 2, if you want to convert into centimeters, the millimeters has to be divided with 10, divided by 10. So 1 by 5 centimeters. These are all the dimensions of the given objects. Now, let us consider the number of required coins be n. Then see, volume of each coin into number of coins we have taken as n is equal to volume of the cuboid. Now we observe carefully, if we want to get the cuboid, we need to melt many coins. Okay, the volume of those all coins is equal to volume of this cuboid. I already told you that whenever we melt and recast, the volume of the objects before and after will be same. So therefore, number of coins is equal to volume of the cuboid by volume of each coin. Okay, now see, observe here, volume of the cuboid. What is the formula for the volume of cuboid? L into B into H by volume of each coin. Already I have told you that volume of a coin can be considered as a cylinder. Why? Because if you keep many coins on this, we will get the shape of a cylinder. So if you remove one by one, then also the remaining part will be in the shape of cylinder. Finally we get one coin that also will be a cylinder with the minimum height. Okay, now you look at this. Volume of each coin can be considered as a cylinder, so pi r square h. Therefore, number of coins n is equal to pi r square h. Therefore, n is equal to L into B into H. What are the length, breadth, height? N into 5.5 into 3 by volume of each coin 22 by 7, pi value 22 by 7. Radius of each coin how much? 7 by 8. Pi r square, so 7 by 8 into 7 by 8. Height, it is given 2 millimeters, we have converted into centimeters, that is 1 by 5. Okay, we need to simplify this. Now 7 will be cancelled. Okay, now here 10 into 5.5 is 55 by 10 into 3. This 22 into 7 will come into denominator, and this 8 into 8 into 5 will come to the numerator. Okay, now let us cancel. Any cancellation is possible. 10 will be cancelled. Okay. Actually, here height is 3.5 centimeters, not 3. Here also. So let us take it as 3.5. That means 35 by 10. Now let us cancel. Here 5 2's. Okay. 2 4's and 2 2's, 2 11's, 11 5's. So let us write all the numbers left over. Here still we have 7 5's. Please observe carefully. You have to do on yourself. Okay. Don't confuse yourself. 5 5's 25, 25 8's 200, 200 2's 400. Therefore, number of coins required is equal to 400. Okay, did you understand? Please copy this problem. Now listen to the 7th problem. A cylindrical bucket. See, look at this. It is a cylindrical bucket of height 32 centimeters. Okay, high, and with the radius 18 centimeters is filled with sand. So this bucket contains sand, full of sand. Now this bucket is emptied on the ground and a conical heap of sand is formed. When we pour the sand in the bucket on the floor, it has formed as a conical shape, into conical shape. Okay, cone has formed. Okay, now if the height of the conical heap is 24 centimeters, the heap of the sand is in the shape of a cone whose height is 24 centimeters. Okay, then we have to find the radius and the slant height of the conical heap of the sand. Okay, now you have to write the dimensions. Here's the radius of the cylindrical bucket. What is the cylindrical bucket? Radius R is equal to 18 centimeters. And height of the bucket, height H is equal to 32 centimeters. And what else he has given? Height of the conical heap, let us take it as H2, and the cylinder height, let us take it as H1. Here radius, let us take the radius of the cylinder is R1. Now H2 is equal to given 24 centimeters. Now radius of the cone R2 is equal to question mark, and slant height of the cone L is also question. We need to find these two, radius and slant height of the conical heap of the sand. Okay, let us find. Now the volume of the sand in the bucket is equal to volume of the sand in the shape of a heap. Okay, conical heap. Now volume of sand in the bucket means that is nothing but the volume of the bucket, which is in the shape of a cylinder. So we can take pi r square h. As we taken r1 and h1, we can take pi r1 square h1 is equal to volume of the sand in the shape of a heap, which is in the shape of a cone, is 1 by 3 pi r square h. Let us take r2 and h2. Okay, now we can cancel pi on both sides. Here r1 square is 18 into 18, h1 is 32, and 1 by 3 into r2 is not given, radius of the cone is not given, and the height of the cone is 24. Okay, now we can cancel 3 8 is 24 and 8 4 is 32. Therefore, R2 is equal to, okay, here we don't have, okay, the height. So we will have 18 into 4. So R2 square is equal to, therefore R2 is equal to, if you remove the square in the LHS, we get 18 into 4. Now this can be written as, root 18 can be written as 9 twos into 4. So 2 into 2, 2 square, 9 into 9, 9 square, 4 can be written as 2 square. Then we get the 2 into 9 into 2, this is 9 to the 18, and 18 to the 36. 36 centimeters is the radius of the cone. Now we have to find the slant height. What is the slant height formula? Slant height L is equal to square root of r square plus h square. We have this formula. This implies L is equal to square root of r value 36 square plus, what is the height? 24 square. Okay, now we will have the r and h. So that is actually the height is given 24. 12 square, 24 square, okay. So this can be written as 36 square. L square is equal to, now how can you write this? 36 is 1296 plus 24. Okay, Nana? Let us simplify in another way. So 36 square can be written as 2 square into, So that is 4 9 36 actually. Otherwise 2 square 2 into 3 12 36. 3 into 12 whole square plus 2 into 12 whole square. So this can be written as 3 square into 12 square plus 2 square into 12 square. Now let us take 12 square common. 3 square plus 12 square will be there in the brackets. So this is equal to square root of 12 square. 3 square is 9 plus 2 square is 4 is equal to 13. Sorry, here 3 square is 9 plus 2 square 13. So root 12 square is 12. 12 of root 13. This is the, therefore slant height L is equal to 12 root 3 centimeters. Okay. These are the radius and the slant height of the cone. Okay. Please copy the problem. Now, eighth problem. Water in a canal 6 meters wide and 1.5 meters deep is flowing with a speed of 10 kilometers per hour. How much area will it irrigate in 30 minutes if 80 centimeters of standing water is needed? Okay, now you listen here. The width and depth are given of a canal. Let us consider a canal is like this. So the water is flowing in this. So the water is flowing in this, like this. So let us consider this as a canal. Its width is given. How much it is? The width is given 6 meters and depth is 6 meters width and depth is how much? 1.5 meters. So the water is flowing in the canal with a speed of 10 kilometers per hour. Okay. Now we need to find how much area will it irrigate in 30 minutes of 8 centimeters standing water is needed. So the water is flowing into a field or in an open place. So there let us some area and up to the height of 8 centimeters. We know that the volume of water is area into height. The area of that land in which the water is flowing into the height of the water needed. The height of the water needed is 8 centimeters is given, standing water. Okay, now first of all we need to find the volume of water which is flowing through the canal. Now I will tell you one formula, that is volume of water flowing through a canal is equal to area of the cross section of the canal into speed of water per hour. This is a very important formula. Area of cross section which is flowing through a canal, volume of water flowing through a canal per hour is equal to area of cross section of the canal into speed of the water per hour. Okay, now volume of water flowing through the canal per hour is equal to, now you tell me, what is the area of cross section? Its width and depth are given. Width into depth, that is 6 into 1.5 meter square into speed of water per hour. What is the speed of water per hour given? 10 kilometers is given. That is the speed. Now 6 into 1.5 is 9.0 meter square. Here it is in meter square, so kilometers also can be converted into meters by multiplying 1000. Why? Because 1 kilometer is equal to 1000 meters. Now 9 into 10 into this is 90,000 meter square into meter cube per hour. So this is the volume of the water flowing through the canal per hour. Now look at this. Now, but he asked us to find the volume of the area of the field if it is irrigated for 30 minutes. The water flowing only for 30 minutes. Therefore, volume of water flowing in 30 minutes is equal to, actually it is per hour. If we want to find it for 30 minutes, that is half an hour, we need to divide by 2. Meter cube. Okay, is equal to 4,500 meter cube. Did you understand? Now this is the amount of water flowing through the canal in 30 minutes. Means half an hour. Per hour it is 90,000. So in half an hour it is 45,000 meter cube. Now volume of water flowing in the canal in 30 minutes is equal to volume of water irrigated into where it was sent into much area it irrigates standing water, okay, into the field or something, somewhere, okay, field. So this is 45,000 is equal to volume of water which is sent into a field is equal to area of the field into area of the field into height. Okay, 4,000, so 45,000 is equal to area of the field which is not given. That only we need to find. Height is given. How much it is given? I think it is 8 centimeters. 8 centimeters. But all the other values are in meters. So let us convert it. 4,500 is equal to area of the field into 8 centimeters can be converted into meters by dividing by what it is? 100. So now, therefore, area of the field is equal to 45,000 into 100 by 8. How much will you get by dividing this? Here by dividing 4 2s are 4 25s and 2 table 2 20 to 500. Here you will get by multiplying 56,200. Okay. Now we get 45,000 into 100 by 8. Here 4 2s are 4 2s are okay. 4 25s are here 225. Okay. Now we get finally 2,500. This is in meter cube. Now we need to find the answer into hectares. Final answer I will write it at this corner. Okay, therefore area of the field is equal to, the field means the area into the water is irrigated, okay, is equal to how much it is? 56,2,500 by 10,000. Why? Because 1 hectare is equal to 10,000 meter cube. So we get finally 56.25 hectares. Okay, this is very important problem. This formula is very important. Volume of water flowing through a canal is equal to area of the cross section of the canal into speed of the water per hour. A volume of water flowing through a canal per hour. Okay, this is per hour. So practice this problem. If you have doubt, so let me remind. Let me know if you have any doubt on this problem still. I will explain in the online class once again. Okay, please copy this problem also. And by this problem we have completed 8 problems from the exercise 3.3. Let us complete the remaining problems in the next class. Thank you. Have a nice day.